put this in the sequence. Okay, this is the sequence. When you add all these, this becomes a series, right? Okay. Now it is correct. See, you can like this is point 0.3, this is 0.03, this is point triple zero 0.003, and this is point triple 0.003. When you add all these, you will get what? 0.33, right? That's why we need a series. The summation of all sequence. So for example, this. Okay, now audible. You understand series? So basically, there are three types of series. One is arithmetic series. Okay. Second is geometric series. And third is harmonic series. Okay. So you know the limit of any sequence. If constant, then it is a convergent. See, compute first few partial sum of S1, S2, S3. Okay. First see, you can write what? 3 upon 10 plus 3 upon 10 square plus 3 upon 10 cube and so on, right? If I say find S1, then take only first term. If I say yes, S2, then first two terms. This is not a sequence. You are you are not finding A2. A2 means second term. You are finding S2. S2 means first two terms. Summation of first two terms. S3 is what? First three terms. Okay. And so on. Right? See, see what is harmonic series? 1 over a, 1 over a plus d, 1 over a plus 2d, 1 over a plus 3d. D is what common difference. It's called harmonic series. Okay. For example, if a is 2 and d is 5, then sorry, d is 3. It means d 3 is added in each denominator. Okay. So this is a harmonic series. Yes. Okay. So this is S1. This is S2. This is S3, right? S4. Okay. S5 and so on. See what is geometric series? Already told you yesterday. Any series in which first term is multiplied, the common number is multiplied in each term. For example, A into R, A into R square, A into R cube. General term A raised to R. Okay. For example, 2 is multiplied with 3, then again 3. Okay. So 3 is multiplied in each term. So this is what geometric solution. And you can write in this way. A R n minus 1. Why n minus 1? Because R starts from 0. Okay. So when R starts from 0 and you are carried up to n terms, then it will be n minus 1 terms. Okay. This is general term. For example, you can see this. If you put k is equal to 1, you will get what? If you put k is equal to 2, put k is equal to 3, right? Anything next to 0 is 1, and so on, right? Similarly, you can do in this way. Understood? And yesterday I told you the sum of GP up to n terms. E 1 minus R raised to n upon 1 minus R. Okay. R cannot be 1. If I ask you, if I ask you to 2 into 5, again multiply 5, then multiply 5, up to 6 terms. Find the summation of above to 6 terms. Okay. So what will you do? You will add manually 2 into 5 square, right? 2 into 5 cube. So you can see these are up to 6 terms, right? But if I ask up to 16 terms, then it will be right. Yeah, to the power 15. Why? Because this is first term, second, third, fourth, fifth, and sixth. So 6 terms power is 5, and 15 term power will be 16. Yes. But I am asking direct without doing this, find the value of summation up to 16 term. Then we have to use this formula. Okay. So write here 6 for 6 term. If n is 6, n means number of terms. A is first term. R is common ratio. Common ratio means what you are multiplying in common. So here you can say A is 2, R is 5. Because 5 is multiplied in each term, right? And N is 6. So you will get 2, 1 minus R is 5. You can also write 5 by 6 minus 1. 5 minus 1. Okay, so 5 raised to 6 minus 1 upon 2. This is the summation. Okay, you can check 5 raised to 3 is what? 125. 125 square minus 1 divided by 2. Okay, this is your answer. Understood? If I ask up to 16 terms, then put 2, 5 raised to 16 minus 1 upon 5 minus 1. So your answer will be upon 2. This is your answer. Okay. Yes. This is direct formula. You have to remember. Yeah. Okay. You can use any formula. You can write this formula also. Why? Because when you take minus common, because minus is multiply on both numerator and denominator, it will not affect the values, right? Problem comes only when you flip one side and you do not flip other side, right? If you are flipping, then you have to flip on both sides. Okay. One more thing, a r n minus 1 upon r minus 1. This is summation for n terms. Summation for infinite terms. If the series is infinite, then you can use a upon r minus 1. This is simple formula. Okay. For example, if I ask you find the sum of this series, then what you can do? You can write 2 over 3. Here 2 is multiplied right? Again 2 is multiplied. Yes. Here A is what? 2 over 3, and R is what? 2 over 5. And you are finding n up to infinity. So A 1 minus R or R minus 1. Okay. If R is greater than 1, then use R minus 1. Okay. If R is less than 1, then use 1 minus R. Here R is what? Less than 1. So 1 is greater. If 1 is greater, then write 1 minus R. 1 minus smallest value. Okay. So A is 2 over 3, 1 minus R. This is for only when you get positive value. Nothing. 2 over 3, 5 minus 2 over 5. So 2 over 3, 3 over 5, 10 over 9. 10 over 9 is the answer. 1.1999. This is your answer. Okay. Understood? If I ask you, find the summation of this series. Here, what will you do? 3 raised to 2, 3 raised to 3, 3 raised to 4, and so on. Okay. So, what will be the answer? This is actually divergence series. Why? Because numerator dominates, right? If you put infinity, you will get what? Infinity. This is divergence series. So, you cannot find the sum of this series. Okay. Now, see 0.99. How can you evaluate this? See, this is very good question, and you can learn new things. See, write zero point 0.9 plus 0.09 plus 0.009 plus 0.0009. Can you write in this way? And so on. Okay? Okay. You know this is what? 9 over 10. This is 9 over 10 square, 9 over 10 cube, and so on, right? Okay? See, yes, yes. 9 over 10. 9 over 10 into 1 over 10. 9 over 10 into 1 over 10 square, and so on. You can see A is what? R is, and N is infinite, right? Summation from N to infinity A upon 1 minus R. A is what? 9 over 10. 10 minus 1, 9 over 10. 9 over 10, 9 over 10 cancel. So approximately what will you get? 1, right? And this is correct. Okay. So what is the exact value of this? 1 will be the answer. Okay, understood? Okay. Okay. What about this? If I say 0.3333, so you can write 3 over 10, 3 over 10 square, right? So A is what? A is what? 3 over 10, 1 minus 9 over 10. 10, 10 cancel, 3 over 9, which you can write 1 over 3. Okay, so 0.1 over 3 is equal to 0.3333, right? And if, when you calculate from calculator, you will get same thing. Understood? Yes. So here you are getting 1. Okay. Now we see ratio test. This is important. Where you are going to check a series is convergent or divergent. We have to check by using ratio test. What does it mean? If the limit of ak plus 1 upon ak is L less than 1, then you can say convergent. If it is greater than 1, this is divergent. If it is equal to 1, then this is neither convergent nor divergent. In conclusion. Okay. For example, if I ask, see this first question. Okay. This is AK. AK means general term of sequence. This is AK. And what is AK plus 1? Just do only one thing. Replace K with K plus 1. Okay. Understood? And find the limit of what? AK plus 1 upon AK. Right? So limit of AK plus 1 is minus 1. Minus 1 plus 1 cancel. So you can write AK. Okay. So what will you do? Minus 1 into K into K factorial upon, because this extreme value is multiplied with extreme and middle value is multiplied with middle terms. Okay. You know very well k plus 1 factorial is what? K plus 1 into k factorial, right? For example, if I ask you what is 4 factorial, then you can say 4 into 3 factorial. Minus 1 raised to k plus 1 into k factorial. And that minus 1 raised to minus 1, right? Is it cancelled? Minus 1 raised to minus 1 is negative 1. If you put k is equal to 1, sorry, infinity, you will get what? 1 upon infinity, that is 0. Right? So your answer will be 0. This is convergence series. Okay. And you can also determine by using dominance law. Here denominator is dominant. If denominator dominates, then value gets smaller. If value gets smaller, you will get 0. Okay. So yes. Because this is not a sequence, this is a series. Okay. So when yes, this is a series. Okay. So in series, you can check convergence or divergence by ratio test. This is called ratio test. So there are many types of tests, in which one of them is ratio test. Okay. Now you can see this. Again, use ratio test. Here AK is what? If sigma is given, then always consider series. Okay. If this is given in a curly bracket, then you can say that it's sequence, right? See, whenever sigma is represented, then this is what series. If this is represented by curly bracket, then this is a sequence, right? Now we will use what? Ratio test. 2k into k square. Two raised to k into 2 k square. Take k square common. K square cancel. Then we put infinity. You will get 1 plus 0, 2. So 2 is a constant. You can say that the series is convergent towards the value 2. Okay. Okay. Can you tell this is convergent or divergent? Yes. You will get, yes, yes. Because you know k is k, k plus 1 is k plus 1, right? So k plus 1 upon k. Put k common. When you put the k, you can do directly. Put 1, 2, 3, right? Yes. Okay. Give a common name of this. So how can you give? So you can see first see common terms. Yeah. Second you can do right by using geometry. First you will do by here 10 is multiply in denominator by e square. So numerator, So you can do one thing. Uh, Suppose you start from here. Okay. So alternate series is there. So first add all these. You will get out 2.7 plus 0.01. You will get 2.71. And in this term, you can see 8 upon 1000 plus 8. 8 means this term. 100. Sorry, this is 10,000. And this is 100,000. So next term we will get what? 6 times 0, right? See, you can see from here to here. Here 30 and here 5 zeros are there. So next term will be 7 term, right? Similarly for this case too, next term will be and so on. Now you can simplify, right? You can see what? Hmm. This is first term and a 10 is multiplying each term, right? Plus okay, 8 upon 1000, 9 upon 10, plus 2 upon 10,000, 9 upon 10, right? 1010 times 0. You can write 2.7, 8 by 900, 12 by 900. Okay, 4 by 450. So final answer will be 2.71 plus 2 by 225 plus 1 by 75. Okay. When you again simplify this, you will get answer. Okay. Yes, this will be long type question. Okay. Calculate this using calculator and write in a form of series in the multiple of 10 as a denominator. So you know 1 over 3 is what? 0.3333, right? Okay. This is 30. 25. 0.757575. Okay. So how can you write this? 75, 75, 75, and so on. 0, 0, 75, right? 4 times 0, 75. Consider 75 as 1 unit. So you can write 75 over 100, 75 over 1000, 40, 60, right? And you can also simplify it in the power of 10. Okay, this is your answer. Okay. Can you tell the first four element of this series? First four element. Yes. Right. So you can further simplify it. Right. So S1 will be S2. Right. And so on. Okay. Right. Is this a geometric series? Okay. So whenever you want to check a series with geometry, this is first one, right? So divide this term to this term. Divide by this term to this term. So whenever you divide AR plus 1 upon AR plus M, A, you can say M minus 1. You will get same thing. Okay, let's check 1 over 2. Here you are getting 2 by 3. Both are same? No. So this is not geometric. There is no common ratio. Here 2 is multiplied, right? But here 2 is plus, right? Again 2 is plus. This is what, this is actually a harmonic series. because 2 is plus in each denominator, right? Now tell me, is this harmonic geometry? There is no common ratio because this is square of natural number, right? Here 4 is multiplied between first two terms, but 5 is added, right? Here 7 is added. So this is not a geometric series. Even this is not a arithmetic series, not neither harmonic series. Okay. The first two terms of geometric series are 5 and 7.5. What is the third term? Yes. No, no. This is geometric series. It means there is a common ratio. So common ratio is what? Any number, any terms which is divided by its previous term, you will get common ratio. Okay. So second term is 7.5 and first term is 5. You will get what? 1.5. 1.5, right? Okay. It means that when you multiply 1.5 in 5, you will get 7.5. Again multiply 1.5 in 7.5, right? What will you get? 1.5 into 7.5. 11.25. So next term will be 11.25. And again when you multiply 1.5 in 11.5, you will get fourth term. Okay. Yes, yes. Common ratio is important. How you can get common ratio? Divide two consecutive terms. Okay. The fifth term of geometry series is 70. The eighth term is 51. What is the sixth term? You know the general term for geometric series is what? A n minus 1, right? So 17 is what? Fifth term. So right here T5. T5 means fifth term. Put n is equal to 5, then you will get 4. And T5 is 17. Okay. And eighth term is 51. Put n is equal to 8. So divide 51 upon AR7 upon 17 AR4. 3. A cancel. AR is 3. Right? So R will be So this is multiplying each term, right? Okay. What is the sixth term? So R is this. Sixth term will be, you will find what? R also. So put any value A. R is what? Raised to 4. So A will be 17 upon 4 by 3. This is the value of A. Okay. So sixth term will be A R5, right? R is what? So you can say 3, 5 by 3. This is minus 4 by 3. 5 minus 4, 1 by 3. This is your answer. This is sixth term. Okay. Yes, very complicated. Yeah. Yeah. Okay. These you all can evaluate. I give one answer. When you put k is equal to 0, you will get 2. Now when you put k is equal to 1, like this. This is geometry series, right? 1 minus r. This is your answer. Okay. So its value you will get 7.123, right? Any question you can do. These are all depend on geometry series. This I already told you how to find expected value, right? See this question. Take k square common. K square cancel. Put k is equal to infinity. When you put k is equal to infinity, you will get 1 by infinity is 0. 1 by 5 is the answer. Okay. So 1 by 5 is less than 1. If the limit is less than 1, this is convergent series. If it is greater than 1, this is divergent series. Okay. can go through it. Okay. So all question you do, it is not important. You just understand the concept. Okay. So next time we will discuss power series. Okay. So after power series, then Taylor series. Okay. We can do that, yes. So we do, you understand today's topic?